Okay, so I want to also give you the definition or kind of the background behind the intermediate value theorem, and it's very common. It's very common, I guess, abbreviation to just call it IVT. So if you have to have a reference the intermediate value theorem on the AP exam or talk about it, saying IVT is the same as like it's very common abbreviation. Okay, so here's what the IVT says. Okay. So suppose you have a function that is continuous, and that is key here, right? It's continuous on a closed interval. So there are two conditions, right? You have to be continuous and you have to be on a closed interval. Okay. And it says maybe k is any value between f of a and f of b. So the thing is that let's go and get a picture here. Oops, I want to go to like maybe a black here to draw my axes here. So here's my y-axis. Here's my x-axis. Okay, so I'm going to have some closed interval a to b, and those are x values, and k is any number between f of a and f of b. Well, f of a and f of b are y values, so maybe that's here, and maybe this one's like up here. I don't know. So if you come over, here's f of a as a y value, and then here would be f of b, come across here, as a y value as well. So what it's saying is that k is somewhere between these. So maybe your k value is here. Okay, there's k, right? So if you know k exists on the y-axis, then there has to be at least one number that they're calling c on the x-axis. So we'll go here. So somewhere there's a c, and I may not know exactly where that's at. Like it's going to be somewhere here. So I'm going to allow that to move. So let me group that together. Oh, it is grouped. Cool. So there we go. Cool. Okay, so I don't know where it's at exactly. There's ungroups, so that's not good. But it says such that f of c equals k. So maybe our function looks something like this. Like here. Oops. Go to my pen. It starts here. Maybe it goes something like this. I wanted a different color. Sorry about that. Let's go to green. There we go. Like some function, what's doing this? I don't know. And it goes to there. Okay, it's continuous and it's closed. Then there's got to be some point. If I think about going across here, there's some point that all of a sudden I find that there's a point where the y value corresponds with some x value down here, and that x value happens to lie, in between. Oh, that's terrible. In between a and b. Okay, so that's it. So it says if you know something along the y-axis, basically everything in between here, all this y-axis, has to be obtained or achieved correspondingly along the x value, all those intermediate values, and that's it. Okay, and so right now, you might be thinking, that doesn't really tell you a whole lot. And I agree, it kind of doesn't, right? But it's kind of like the building block. It's sort of setting some things up of what we're going to need to start building our calculus foundation. What it should also be noted that this is an existence theorem, okay? So it doesn't tell you what it is. It just says it's there, right? And you have to go and find what that value is. And that could be through algebra or through graphing or some other approach that we'll look at in class. But ultimately it just shows it exists. It's guaranteed to be there. You would have to find it. Okay, so that's the intermediate value theorem. And again, I think the picture really helps determine and show a lot about the theorem that, given a closed and continuous function, that if you know that there's some y value in between the known y values, it will have to have been achieved somewhere on the x-axis. Then you have to go and find that value. Okay, so that's sort of like the introduction to intermediate value theorem. So then in class tomorrow, we'll go ahead and take a look at how does that apply to a particular problem.